Cool. Thank you, Eric. Yes, Eric and I have been traveling Poland since Sunday. We're best buddies. We started in Krakow, and now we're in Warsaw. And that was kind of the extent of our tour, but it was a lot of fun. So this whole event is about events, right? Event-driven architectures. And as my good buddy Eric likes to say, event-driven architecture is essentially something happens and we react, right? We do something about it. It's pretty simple. It works. So we've got all these data changes. We use events as kind of the connective tissue between all of these back-end systems. And as Eric already kind of said, there's almost always some human interface in the loop, right? If you were in James's talk just now, he's got like a food delivery app. I've got a food delivery app. If you think about an e-commerce, right, you've got the loyalty system, and you've got the delivery system and the invoicing and all of these different systems, and we're trading events back and forth. But there's probably somebody like me sitting there as well, waiting very, very impatiently for their food to show up or to see where the package is. And I obsessively track these things. And as Eric said, the obsessive tracking guy, I'm Josh Kahn. I'm the worldwide tech leader for serverless at AWS. So I work with customers on serverless architectures all the time. And we have this big community of internal experts called the technical field community, of which I think we've got about 1,100 people on serverless at this point around the globe. So if you ever need help, we probably have someone here. But you end up with some app that looks roughly like this, and forgive my poor user interface design skills. But there's some food delivery type app or delivery app where we want to know, hey, where's my food at? What state is it in? Maybe we're tracking the driver to see them getting closer and closer and closer. But it's not just in the mobile world. This is actually from Eric and my trip here in our stop off in Frankfurt, in case you're interested. But there's these types of things out there as well. And if this, the boarding information is wrong, you're likely to end up at the wrong gate. Maybe you're going to miss your flight. It's not a good situation. But if you think about the airport, it is entirely event-driven. It's maybe not quite as simple to conceptualize, but when the plane is ready to board, this should change to boarding, like some of that flight to Edinburgh, for example. Train stations have these things. They're all over the place. In fact, if you got a coffee today from other than the self-serve machine, you've seen this in practice too, right? Serverless espresso is very much event-driven. And what's cool is it actually shows off both of the kind of patterns that we're going to talk about today. On the one hand, you've got the broadcast side of the booth, right, where you've got the big screen. It shows everybody's order, what's in process, what's ready for pickup. This is more of a broadcast use case, and I'll explain that again in a minute, but you can also keep track of your own order on your mobile device and see what state it's in as well. And as these things change, they get updated as well. So what was weird is I've worked the serverless espresso booth a time or two in the last few years, and often people would come up to us and ask, how do you do this? We tried to do it and it didn't work. It's not so simple, right? Connecting the front end and the back end, because they often involve different teams, different technologies, a different approach. So I started thinking about, okay, how do I explain this? Are there some general patterns that we can share? And there are, believe it or not, that solve both of these use cases. So the talk, by the way, is designed for front-end engineers. We're going to focus mostly on cloud principles, though, so we're going to also do some back-end engineering, if you will. Back-end engineers in the room, there's going to be a very small amount of JavaScript code. I promise only a little bit, but it does need to be there. If you're a full-stack engineer, you're in the right place. If you're one of those mythical 10x engineers, also probably okay, but maybe you can play it at double the speed. So we're going to take a look at all of these things, all possible on AWS today. But user interfaces themselves are just inherently event-driven. When you're scrolling on a page, when you click on a button, there are events there. If you didn't know, your browser, if that's what you're using, a web application, knows how to link into these things. So here's just a little bit of React, right? So I've got this on-click handler. When somebody clicks on that button, something's going to happen. Somewhat basic, right? But we're just going to pop up an alert here. Every one of these things is an event, and we want something to happen in some cases. Sounds familiar, right? But oftentimes, like we might have click a button or the page loads, which is also another event, and we're going to go load some data. But in a lot of cases like this one, this is very, very static, right? That data is not going to change. And it's also very synchronous. But stuff's happening all over the place, right? We know the world is asynchronous. My pizza is getting closer to my house, at least hopefully. My package is hopefully going to be delivered, although some days I worry about that one as well, so I check obsessively. So we often take this pattern of loading a whole lot of data up front synchronously and then doing asynchronous updates. That's a good way to think about that flight departure board as well, where we go load the bulk of the data up front and then just update individual flights as we go. Because real-time data really does make the experience better. Hopefully I don't have to convince you of that. Whether it be a food delivery service or a stock ticker, a sports score app, anything like that, it really does make it better. But again, if you've tried to build this, it's not so simple. So a very common way that we see people implement this is with polling. You have the client, which I'm going to always show as a mobile device, but it can be other things as well. You're always polling, and the client on just a regular basis is calling and saying, hey, do you have any data for me? If you have kids, you know this behavior. This is the kid sitting in the back seat of the car asking, are we there yet? Are we there yet? Are we there yet? It's bothersome with the kids. It's needlessly chatty here, right? Because it's constantly taking up network resources. Oftentimes the server's not returning anything new. It's the exact same response. So it's not useful, it's just expensive. But if we wanted to implement polling on AWS, pretty straightforward to do. The right side of this diagram is going to start looking familiar, by the way, because I'm going to use it over and over again. But we've got some central event bus, probably event bridge in this case. I like Lambda. You could do this other ways, but I like Lambda, so I have a Lambda function that I call an event handler that gets invoked whenever a particular type of event or events show up, right? Like the delivery app changed some state, or the order changed some state. My Lambda function writes into a DynamoDB table. I'm calling it the view model table. We'll talk about why in a few minutes. But then this one's a little bit different than the rest. When my client wants an update on let's just stick to one order. Like when my client wants an update on that order, it makes a synchronous REST call to API Gateway. API Gateway invokes a Lambda function that goes and gets the data and returns it back to the client. Really simple, right? You've probably built this if you like Lambda, like I do. Really simple. And most REST APIs, you can pull them. That's why it's popular. People understand the semantics of REST. We have lots of RESTful APIs. The thing is, there's some challenges here. Maybe not immediate, but there are down the road. So polling tends to not be the best user experience at times. It feels really slow to users because unless you're polling like over and over and over again, we'll come back to that in a second, it's going to feel slow. The updates aren't going to come in as quickly. But if you are doing that really rapid polling, you're putting a lot more stress on whatever the server is. Now in this case, Lambda is going to just scale up most likely to handle what you need. It's kind of hard to push past it. You might need a support request, but we do that for you. Eventually, though, you're going to hit some upper bound, but you keep getting this wasteful, chatty communication over the network. And again, you're asking for data that hasn't changed. Now, actually, the hardest part here that you probably don't think about is how do I calculate the delta? So how do I figure out what changed from a request 5 seconds ago to the request that just came in? And if you're like me and you write somewhat questionable code, you got to test it. right? So that to me, especially like with complex state, that's the hardest thing, is figuring out what changed from one request to the next. Now there are practices you can use to improve polling, make it more effective, take away some of those negatives. But to me, I prefer a more asynchronous approach. And the rest of the talk, we're going to focus on async, subscription-based ways of updating your user interface. It's probably why you're here, frankly. So here we've got our client app again, and it basically just says, hey, server, backend, just let me know when data changes. Again, back to our kids, or my kids at least. This is saying to them, hey, I'll let you know when we get there. Leave me alone. And then you have a nice quiet ride, hopefully, and can listen maybe to a podcast. Rarely happens. So this, again, is really good for small data updates. Like the position of the driver has changed, or a flight is now boarding, right, or delayed, hopefully not canceled. You're not going to load the entire flight status board here. Most of the subscription patterns that we're going to, actually all the subscription patterns we're going to talk about today use WebSockets. Pretty common. Again, it's pretty well-known technology. There's different ways that you can use them. You might have also heard of things like webhooks, which is another way that you can update, kind of let some subscriber know that data has changed. Webhooks tend to be less useful in this user interface world, right? They just don't, they're not quite as effective as when you would use them for like server-to-server communication. So there's 3 different kind of interaction patterns that I'm going to talk about and how you can implement these. The first is real-time events. We've already been talking about what that is. Some state changes, we want to update the user interface. The second I called long-running processes. Frankly, this came up because generative AI, right? Like that's what people are talking about, believe it or not. But one of the challenges here is that your LLM or your model might take minutes to respond, and something like API Gateway has a 30-second timeout. And at that point, it just responds with an error. That's not useful. So we've actually spent a lot of time working with customers to implement asynchronous patterns to deal with that, so that if it takes minutes to respond, it's okay. There's actually another use case that I'm going to show when we get into that section a little bit later. I did a reInvent talk last year on how to pick the right API front door. And I had a very small diagram in the upper right-hand corner that I'm going to show you. And that elicited far more questions about how to implement that than anything else after the talk. It was kind of an afterthought, but it was just funny. Very, very, very briefly at the end, I'm going to talk about push notifications, because they're kind of like real-time events, but the semantics and the technology are actually different. And you've got a third party in the middle. You can't send push notifications to a device without getting Apple or Google or Firefox or somebody involved. Sound good? So just breezing through, this is our very simple conceptual architecture, food delivery service. We've got all these services. They emit events, and I'm focused on what we're calling the backend for front end, which might be a pattern that you've heard before. For this use case, I liked it. It worked really well. A backend for front end, or BFF, is a very common architectural pattern that tightly couples what your front end, whether it be a web application or a mobile app, needs with an optimized API. Now in this EDA world, we tend to talk about coupling as being a negative to some degree, right? We tend to talk about decoupling a lot. The thing is with this pattern, it actually works really well. Teams actually gain some more autonomy, and they have a better separation of concerns, because if I've got a BFF for my iOS app and a BFF for my web app and a BFF for my Android app, those teams can implement what they need and provide the orchestration, persistence, and aggregation that that front-end layer needs all by itself. So there's a demo that we're going to see in a little bit. The source code is out on GitHub, and you have to stay to the end to get the link for that, sorry. But I've actually implemented the BFF for all of the patterns that we're going to see. It's just a thin slice though. So it's basically what I needed to push the updates out to the front end. You could totally take it and expand it out the rest of the way if you wanted and do all of the persistence. So just one more piece of terminology that I already touched on. two types of notifications or subscriptions. The first is what we'll call broadcast. This is the big board out there at Serverless Espresso. It's telling everybody the weather in my hometown, Chicago. And then there's point-to-point messaging as well, and that's sending you an update about your individual order, right? That's Serverless Espresso on your phone if you ordered a coffee. All right, so let's get into some of those patterns. And by the way, on broadcast versus point-to-point real quick, the reason I bring those up is because how you implement that in each of these patterns involves some trade-offs. So if you need to support both broadcast and point-to-point, some of these might work better than others. Okay, so let's talk about real-time events. This is going to be the longest section because, frankly, all of the others build on top of it. So the first pattern I'm going to call real-time events with AWS AppSync. If you're not familiar with AppSync, it's a managed GraphQL service. GraphQL is a query language for APIs, and it was meant to address some of the challenges with REST. Basically, what's cool about GraphQL is the client asks for whatever data it wants back. There's a schema that the client and the server share. The client says, hey, I only want these fields. That's all it gets back. Versus in the REST world where the server really controls what comes back to the client on a given request. GraphQL, very briefly, has three types of operations: queries that get data, mutations that change data, and subscriptions, sounds useful, right, that listen for changes to data. Some people don't like GraphQL. You might not like GraphQL. I think it works really well for these types of data-driven use cases, particularly because it has that built-in subscription functionality. So let's talk about the pattern. I'm only going to go through the right side one time because, again, it's a little bit repetitive. Or I guess this is a second time. But we've got our event bus. It publishes some events. We have a Lambda function that we call the event handler, subscribe to those events. The event handler parses out what of that order update it wants and writes it to that DynamoDB view model. Okay? What's different? So now we're actually going to publish those changes on a DynamoDB stream. And we have a second function that I call the stream handler. That stream handler takes those events off the DynamoDB stream and basically figures out, do I want to publish something about these? And if it does, it performs a mutation, and I'll come back to that in a second, against the AppSync GraphQL API. With AppSync, you use mutations or data changes to invoke a subscription. So AppSync will automatically say, hey, I have a client that's subscribed to listen to this data, and it will automatically publish that data out. It's pretty nice because there's not a lot you need to manage except understanding the schema itself. So some of the benefits here, you can extend this pattern to pretty much any data source that supports this type of change data capture. So I'm using Dynamo here because it's really flexible. It does exactly what I need. You could also throw Neptune in, which is our managed graph database, not related to GraphQL, by the way. You could put Aurora there. Basically anything you can do change data capture, this would work for. So a really flexible pattern. You can also take advantage of some of the features that the Lambda event source mapping, or ESM, provides here. So you can filter the DynamoDB stream. If your stream handler only cares about certain events, or maybe only cares if like something's getting inserted into the table, you can define that with configuration and your function's never going to be triggered. This also does some things like batching, right, and automatic error handling. Although I think the error handling session's going on at the same time right now. Sorry. So again, you have a lot of flexibility that you can build into this. There is some additional complexity here though, right? You've got to use GraphQL. There's a couple of Lambda functions that you need to mention, need to take advantage of. Again, GraphQL is okay by me, but you may make other decisions based on what you're doing in your organization or what knowledge you already have. This pattern does use a WebSocket connection. So essentially what happens is the client says, hey, I want to subscribe to these updates. It performs a subscription operation against the AppSync API. AppSync will return a secure WebSocket URI, and then the client will open a connection up to that, and they do a handshake, and you can see it all in the web console if you really want to. This is a one-way WebSocket connection though. AppSync can send data to the client. The client cannot send data back. Now that also might be a trade-off depending on what you're building. And if it is, we'll look at a pattern in a few minutes that actually works around that. Down at the bottom of every one of these slides, I've given you kind of the auth cheat sheet, if you will. So AppSync is very, very flexible. It supports both AWS IAM and Cognito. You can do a custom authorizer with Lambda. You can also do OpenID Connect. But there is no public endpoint for AppSync. There is no way to just put it out on the internet. And in fact, for the demo, I show you how to implement, we'll call it guest mode, so that it is really using IAM under the covers, but you don't need to, your user doesn't need to be signed in. So there are ways to do it, you just have to work around it. I'll also show you in just a minute how you can do both broadcast and point-to-point with this approach very, very simply. So broadcast versus point-to-point, pretty straightforward. There's this thing called a GraphQL schema. That's kind of the interface, the contract between your client and your server. The way I implemented it, and there's not a ton of contrast there, but the way I implemented it is I have a subscription called onCreate or update order, and you can optionally supply an order ID. With GraphQL, you can make a parameter required by adding an exclamation point after the type. So in this case, if I specify the order ID in this subscription, I will only get updates for that particular order. And in the demo, you'll actually see that at the top of the screen. There's one little widget that only cares about the order it just placed, essentially. But if I don't specify an order ID, it's going to get every update that comes in. And again, kind of the second little bit, and again, it's a little bit hard to read, but essentially there's two different mutations here, create order and update order. And we use this AWS subscribe directive in AppSync to specify that this subscription should be triggered when those mutations are invoked. So just a little bit of wiring. On the client side, again, this is pretty straightforward to deal with. You know, I can either specify an order ID or not specify an order ID. And this uses Amplify. There are other ways to connect GraphQL APIs. Second pattern looks a little bit like the first, but it's actually a little simpler. In this case, we are using a direct integration between EventBridge and AppSync. We've eliminated the Lambda functions, and maybe that's the most serverless thing of all that we can do. Right, Eric? So in this case, we have EventBridge. It just calls the AppSync API directly. This is really, really simple. There's not a lot of icons on the screen if that scares you. That said, though, you are kind of reliant on the input transformer that EventBridge provides in this case. Because what we do is EventBridge is actually going to take the payload, the event payload, the order update, and it's going to kind of transform and twist that information into the input that AppSync expects, right? So there's a little bit of mapping that goes on here. It kind of does what it does, and if you needed to do more than that, you probably don't want to use this pattern. That's the trade-off, if that makes sense. With both this pattern and the first pattern, you can also do this with private APIs. So if you only wanted your AppSync API to be accessible via like a VPC or a VPN connection, you can set that up if you want to. Subscriptions will work. You just need to use this domain name that AppSync provides, not a custom domain name. Again, the GraphQL is just one way. And what we're actually doing here is AppSync has these different data sources. So earlier we used a special thing called none, which is more of a pass-through. Here we're using the baked-in integration between AppSync and DynamoDB, and you write a data mapping using JavaScript or Velocity Template Language, VTL, which is scary, and people in the audience are shaking their head no. Yes, most people like JavaScript. Makes it a lot easier, but you're actually doing all of this configuration through whatever infrastructure as code or whatever approach you're using. And yes, there is a lot of boilerplate and a lot of examples out there on how to do it. So to set up this integration, I just wanted to spend a minute on it because it's really friendly and nice. You can either go into the console and then pick AppSync as an EventBridge target. And then the EventBridge console is actually smart enough to go look at your GraphQL schema and figure out what mutations are available. So it'll actually give you a drop-down list, and you can just pick create order, for example. And then you can configure your input transformer. We'll look at it in a second. But basically, this is how you could wire it all up in the console. And what's nice, but not shown here, is there's actually an export button. So you can go export this configuration to CloudFormation. If that's your IAC of choice, you can probably convert it to Terraform or CDK or whatever else you use if you wanted. But as I was trying to figure out this feature, when it was in beta, that was really, really helpful because the docs weren't done. Contrast. So if we were to put this into CloudFormation, this is what it looks like. I'll just try to point out what's important here. But there's something called GraphQL operation. And this is where we actually specify the mutation itself, okay? So this mutation is 100% what it would look like if you were invoking that mutation using a GraphQL library. You can get pretty detailed, you can specify the input, and then this is where you actually specify the fields that you want to come back for the mutation. I'm gonna come back to that in a second because it's a really good tripping hazard. Further down, we can specify the input transformer, and this is where in EventBridge we specify these are the fields from the event that we want to take and how we want to transform that into the payload that gets sent to AppSync. I prefer to have one input as opposed to trying to map all of those to different parameters. It just makes things simpler. One quick trick is if you wrap these things in quotes, it's a string, but you don't need to do that. So in this case, I actually had an array, JavaScript array, and by not putting quotes around it, that's what I got out. That took a minute for me to figure out. So maybe it solves a problem for you too. All right, so one other thing I just want to mention about mutations and AppSync, because this is a tripping hazard people run into, even when they're not using the EventBridge implementation, or integration, I should say, is that the selection set matters. So selection set is this stuff. It's the set of fields that the GraphQL server is going to return to the caller when that mutation gets invoked. The way AppSync works, this is also the list of fields that will be available to subscribers. So even though this is fire and forget, right? EventBridge is going to send that mutation to AppSync. EventBridge does not care what the response is. It cares if it's an error response, right? But it doesn't really care if it's successful. But if I've got a bunch of subscribers, a bunch of mobile apps looking to see where their order is, and I don't include, for example, let's say order ID or the number of items in the selection set, I won't be able to see that in the subscription. It'll just come back as null. Hopefully that makes sense. It's kind of subtle, but it will save you a lot of time when you're wondering why num items is always null, hopefully. So my preference is to specify every single field, even though EventBridge or whatever my caller is, even though they don't care, I specify everything so that my subscribers have access to all of that data if they want it. And maybe one day if you ever go do this, that long explanation will jingle in your head and it'll save you a few hours of time. All right, so let's get away from GraphQL. So next, we're going to look at how to use Amazon API Gateway to implement that same pattern. There are more icons on the screen, yes. So we've got the same thing. We've got EventBridge, triggers that event handler. The event handler writes data into our DynamoDB view table. It publishes those changes to a stream. And then we've got this stream handler that then goes and calls this WebSocket endpoint. But there's more. Connection management in this case is a little bit more do-it-yourself. So whereas the AppSync patterns, AppSync kind of took care of managing subscribers for you, With API Gateway, you need to manage it yourself. So what we'll do is we have our client. The client is going to register with the endpoint and say, hey, I want to connect. The way I've implemented this is I have a connection handler called onConnect. There's also a second connection handler called onDisconnect that I'm not showing here. And basically what happens is this connection handler writes data to a second DynamoDB table. I'm calling it the client table. And it's just got some unique identifiers for this particular client. We do have patterns on serverless land and other places that you can use to go implement this very, very quickly, but there is more code for you to manage. Okay, so back to our stream handler. I get an update on a particular order, 1, 2, 3, 4. The stream handler actually needs to go to that client table and look up which clients, which connections care about order 1, 2, 3, 4. So there's a second query involved here that we didn't have before. And then the stream handler publishes that information to our WebSocket endpoint. It needs a permission called Manage Connections on API Gateway in order to do that. And every one of those messages is going to get sent one by one. I'll come back to that in just a second too. So a few more moving pieces here, but there are some advantages depending on what you're trying to do, depending on what you're trying to achieve here. So again, more moving parts. You need to do some DIY connection management. But if you're building something like a chat application where you want to have that two-way connection between the client and server, you can do that here, right? So API Gateway supports two-way communication, unlike AppSync in the previous two examples. You can also create a public WebSocket endpoint, right? That's just totally public and open. That's what I did for the demo just to show how to pull that off. But you can also wrap IAM and Lambda authorizers here. There is no true broadcast messaging with API Gateway. There is no way for me to just announce to the world the weather in Chicago. We actually have to go and query our clients table and look up the list of subscribers and then iterate through that one by one in our stream handler in this case to send that update message. So there's some more work here, again, depending on what you're trying to do. But this pattern, this approach works really well for certain types of applications, certain types of workloads. Maybe you want something a little bit more interactive. Collaborative writing apps are another common example that people would use something like this for. Sound good? Eric, I have no idea what time I'm supposed to be done now. 10 minutes, okay. Okay, fourth pattern. This one uses IoT Core. It's kind of similar to the first pattern and the third pattern, but it uses this IoT service that we've had for a long time and is actually really, really friendly for what we're trying to do. So I'm not going to boil the ocean on how the pattern works. It's pretty much the same as what we've looked at. But instead of the stream handler calling AppSync or API Gateway, in this case, it's going to send a message using IoT Core. So IoT Core is a publish subscribe model based on MQTT. And MQTT is a lightweight publish subscribe messaging protocol that's primarily designed for remote devices that have very minimal code and bandwidth available to them. Things like switches and attenuators. Our mobile phones, our laptops are much, much more powerful than that. Okay, they don't have that problem generally. But this is really simple and straightforward to go implement as well. It's very flexible because it's topic-based, and you define the topic with a string. Again, though, if your code is questionable like mine, you might fat finger something, and one of our colleagues has said before that, configuration by string is always a little questionable, right? So you do want to be careful with it. The difference between a broadcast message and a point-to-point message, though, is really just that topic name. There's even support for wildcards here. So it's very, very simple to go implement on the back end. If you are doing true point-to-point messaging, though, you probably want to have an IAM policy that limits who can see particular topics. Because I probably don't want the whole world to see where my pizza is, although who really cares? But if you have something more sensitive, you do need to implement a policy around that. This also does support two-way communication. So you can have the client send data back. Now that said, this is a single endpoint per region, per account. So with IoT Core, you get a single DNS entry that you have to use across that AWS account in the region. You can get it in CloudFormation, in the CLI, in the console, but you might need to do some like Route 53 DNS magic if you want to kind of hide that name or use it for multiple workloads. The other thing to keep in mind is that the auth options are not the same. You basically have IAM or Cognito, or you can use an X509 certificate, which is really more for devices than they are for clients like the ones we're talking about. So IoT Core, in order to do the client subscription, again, it's really simple for broadcast versus point-to-point. We just changed the topic name. This was super, super simple to set up on the back end. I cannot stress that enough. In fact, this is how Serverless Espresso does what you see on those boards and on your mobile devices. The front end, not so much. I actually struggled a lot here because React kept trying to connect multiple times for some reason that I still cannot figure out. It probably had something to do with the library I was using. All right, live demo time. Yeah, we don't want to see the video, although that's here too. Just to give you some idea of what you're about to see, there's a front end application built in React. Pattern number 1 is not there. It's actually the polling pattern that you're going to see instead. But basically, I've got a mock order simulator that we're going to start running in the background. It uses step functions and event bridge scheduler, basically to just start sending fake order data at random intervals and running through a process, an orchestrated process. And you'll start to see, if I'm able, when I get the demo going here, that is the wrong one. There we go. When I get the demo going here, oh, nope, that is the video. Sorry, AV fail. Eric, why didn't we practice this before? You're not taking the ramp. That's the wrong one. Okay. Where are you at, Chrome? There we go. All right, so we're going to start the simulation. You're going to see this guy up at the top. This is the little widget up at the top is only going to listen for updates on this order. All of these others, which we need a little refresh, sorry. See, this is what I get for doing a live demo. All right, so we're going to start to see a bunch of stuff, not necessarily. I should have gone with the video. There we go. Okay, so you'll start to see it's going to start populating things. So the polling pattern is only polling every 15 seconds. Now I could reduce that interval and you'd start seeing messages showing up a little bit earlier, a little bit more often, but just trying to show the differences here. All of the others are pulling data off of that more subscription-driven approach. Now there are some differences in terms, I know it's a little hard to see because I think I actually have it running 2 times right now. But there are some differences between kind of latency and ordering at times here. And the reason behind that is because a couple of these do use DynamoDB streams. So there's batching going on in the background. It's not delivering every single event on the stream immediately. It actually batches those up over some time. You don't see that with pattern number 2 as much. And once in a while, the ordering will be different in terms of how they show up as well. So if you'd like to see this actually run properly, I'm happy to either share the video or all of the sample code is out there on GitHub. You can go deploy either all of these patterns or just a couple of them to your AWS account. And then all you need to know how to do is install NPM or Node and just spin it up, hit that local host on your browser, and it will actually run. There are also web push notifications in here. You might have seen it pop up just briefly, but it only shows up for one event because push notifications can get annoying otherwise. All right, so that was real-time events. Let's take a look at long-running processes, and Eric will eventually wave to me when I'm supposed to be finishing up. So this is just a generic, I've got a long-running process. In this case, I'm invoking Bedrock, right? But I'm actually using AppSync again. So this, I like this approach. It works well, but you can do it with any of the 4 patterns we looked at earlier, believe it or not. This is using, I believe, pattern number 1. So what I'm going to do is I'm going to have a mutation called send message. This is kind of a chatbot with LLM to help you place your pizza order. It's then going to go start the execution of a step function state machine. Maybe we're writing some data into Dynamo, but of course invoking Bedrock is kind of the long-running part of this. It could take longer than 30 seconds because AppSync also has a 30-second timeout, like API Gateway. When Bedrock finishes, we are going to send an event to EventBridge. I love step functions because I can do all of this without writing any code. And then that event is going to eventually be published to AppSync. Again, this is that direct integration, so it's actually pattern number 2. We can then trigger the subscription to send across to the client and update them with the response to from our LLM. Again, this can run for minutes and even longer than that if you want to. That connection will stay open for up to 2 hours. So really powerful pattern. This is a great place to introduce asynchronicity between the back end and the front end because of how long the model might run for. This is that diagram I talked about earlier from my reInvent talk that was like way up in the corner and everybody came to ask me about it. So in this case, we're actually doing some data queries. And what we're doing is we have Amazon Athena, which is querying data in S3. Again, that's an asynchronous process. It can take a while. And when Athena's done running the query, it will actually write the results into another S3 bucket. So what we're doing here is we've got our client, it starts the query. Again, we're just using AppSync. AppSync can actually directly invoke other AWS services as well, just like API Gateway, no Lambda functions. We're going to run the query, and then when the results hit that results bucket, we can use the event to go invoke another Lambda function. That function then goes and calls the AppSync API mutation to send a subscription across to the client, and then maybe we deliver like an S3 pre-signed URL to go get the results. So again, this is another use case where you're using a lot of these same processes, a lot of the same technologies and patterns that we use to power something like Serverless Espresso or the flight departure board, but for a much more business-oriented process. By the way, my preference here is to use IAM when I have Lambda calling AppSync. Why? Because I get those short-lived credentials. I'm not constantly updating API keys. But AppSync supports multiple auth options, and you can even do it per type or per operation. So you can use this in multiple different ways. All right, last little section here is on push notifications. Again, these are kind of similar to that first group of real-time events, but there's different semantics and technologies involved here. The other thing is you probably don't want to change send a notification every time the state of your pizza delivery order changes, right? That would become really, really annoying, and notifications are annoying enough. So in the demo, I filter it out so that it only sends you a notification when your pizza's out for delivery. So this is web push. So if you didn't know it, your browser can handle notifications just like your phone. You probably get those prompts from websites that say, would you like to hear from us every 30 seconds? And you probably say no. But that is a prerequisite, particularly with Safari. They are Safari's very, very strict about making sure the user gives explicit permission. Right? The website can't just all of a sudden say, hey, Eric subscribed for these updates. It's okay, you can trust me. You actually have to pop up a user interface element for them to click. So as a prerequisite in this pattern, I've got, again, I just used API Gateway here, and it's a proxy to EventBridge. But first, it's going to pop up a system notification that says, do you want to allow notifications from this site? And you have to say yes if you want them. And what will happen is the client will then register some keys, we'll just leave it at that we're going to write into a subscriptions table in DynamoDB. What does that mean? That's 2 minutes. Okay, thank you. Too many, it can mean anything. Yep. So we're going to go register that subscription. Then when the order change comes in, our event handler, again, needs to go look up, hey, which subscriptions care about this order? And it's going to publish that update through a notification service. This is the third party, right? So it might be Google, it might be Apple, it might be Firefox. They are the ones that are actually responsible for delivering the notification to the browser in this case. Now the demo code does walk you through how you can go create the keys you need to do that, but there is kind of a precursor there as well. On the mobile push side, again, it's a little bit different. You have to register as a developer with Apple or Google. This slide shows Pinpoint, but I think we actually might be calling this mobile user notifications or something now. They changed the name of it slightly. But once you have those keys from Apple or Google, you again are going to kind of register the device using that unique device token with Pinpoint or whatever it's called now. And then you still do need to associate the order with that customer ID. So Pinpoint gives you a nice way to do this because you can add some metadata to that particular device. It makes it easier to go look up which one do I need to go send the notification to. But again, that notification goes through Apple or Google. All right, so those are the different patterns we looked at. If you want the sample code, that's the QR code and the short link to get there. So we looked at the 3 different interactions, 6 different patterns-ish to go deliver them. Hopefully this was useful and you kind of go wire up some real-time stuff on your front end now. But thanks for coming. Enjoy the rest of the day.